All right, so you want to break into cloud engineering, right? Then you've definitely heard about Terraform. Well, today, we're going to cut right through all the noise. This isn't just some boring technical talk. Nope. This is your job-ready roadmap. We're talking a clear, step-by-step guide that'll take you from knowing nothing to actually managing cloud infrastructure with code confidently. So let's get started and build that blueprint.
I want you to imagine this for a second. Total chaos, right? You've got different teams all over the place, no master plan, things are breaking left and right, and there's absolutely no way to repeat what you just did. Sound familiar? Well, that's exactly what managing cloud infrastructure by hand, by clicking around in a console, feels like. It is a recipe for disaster. And that is the core problem Terraform was made to solve.
So you've got two worlds here. On one side, you have the old way, manually clicking through a web console. It's slow, you're bound to make mistakes, we all do, and trying to track who changed what, forget about it. It's just not scalable. But then, on the other side, you have infrastructure as code, or IAC. This is where you define everything in a simple text file, your blueprint. And what does that get you? It's fast, it's repeatable, and it's version controlled, just like the code your developer friends are writing. It's a game changer. Okay, so how do we actually start writing this blueprint? That brings us to our first and maybe most important section, laying your foundation. This is where we get into the nuts and bolts, the fundamental language, and the core workflow that, trust me, you are going to use every single day as a cloud engineer.
The language Terraform uses is called HCL, which stands for HashiCorp Configuration Language. Now, the key word I want you to focus on is human readable. Seriously, don't be intimidated by this. This is not a heavy-duty programming language like Python or Go. It's what we call declarative. That just means you describe what you want to build, not all the nitty-gritty steps of how to build it. You just say, I want a server, and Terraform figures out the rest.
And look at this. A basic Terraform file is actually super simple. It really just boils down to two main parts. First, you got to tell Terraform which cloud you're talking to. AWS, Azure, Google Cloud, whatever. That's called the provider. Then you just give it the instructions for what you want to build. Maybe a virtual server. We call that a resource block. That's pretty much it. Provider and resource. Simple.
No matter how wild and complex your infrastructure gets, you're always going to come back to this core four-step workflow. First, you run Terraform init. That just gets your project ready. Then, and this is super important, you run Terraform plan. This gives you a preview, a sneak peek of what's about to happen. It's your safety check. Once you're happy with the plan, you run Terraform apply to actually build the thing. And finally, when it's time to clean up, Terraform destroy tears it all down. So remember, prepare, preview, build, and clean up.
All right, before we go any further, let's lock in some really good habits right from day one. There are two little commands I want you to get used to running all the time. First is Terraform FMT. That's FMT. It just automatically cleans up your code formatting so it's nice and readable for everyone. The other one is Terraform Validate. This does a quick syntax check for typos and errors. Seriously, think of these two as your personal little coding assistants, always there to make your life easier. Okay, so writing a blueprint for yourself, that's one thing. But what happens when you're working with a team? Now you've got multiple people all trying to work on the same master plan, and you really don't want to step on each other's toes. This is where we get into one of the most, and I mean most, critical concepts in all of Terraform. So Terraform needs a way to remember what it's already built. It needs a memory, right? And that memory is called the state file. The easiest way to think about this is that it's the official record of your infrastructure. It's the master plan that maps every single thing in your code to the actual real-life thing running out there in the cloud. It is the single source of truth.
Now, when you're just messing around and learning, Terraform will just save this state file right on your own computer. We call that local state, and it's totally fine for practice. But in a team, oh, that is a huge problem. What happens if your computer crashes? What if your teammate needs to make a change but you have the file? See the issue? That's why every professional team uses remote state. They store that state file in a shared, safe place, like an AWS S3 bucket or Azure Blob Storage, where everyone can access it.
But wait, what if two people try to make a change at the exact same time? You could completely mess up that shared file, right? Corrupt it. Well, to stop that from happening, Terraform has something super clever called state locking. It's basically a do not disturb sign. When you run Terraform apply, it locks the state file. That means nobody else can touch it until you're done. It's a simple idea, but it's what makes working together on a team both safe and predictable. All right, so as you start building bigger and bigger things, you're going to notice something.
You're writing the same code over and over again. Okay, I need a virtual network. Again. And another database. Again? You're thinking, there's got to be a better way. And you're right, there is. And it's called modules. Let's dive into how we can build stuff way more efficiently.
Honestly, the best way to think about Terraform modules is to just think about Legos. They're like prefabricated building blocks. So instead of building a server from scratch every single time, you can create one perfect server module that has all your team's best practices baked right in. And then you just reuse that Lego brick wherever you need a server. It makes your code so much cleaner, you make fewer mistakes, and managing everything at a large scale becomes, well, manageable.
Okay, so we've covered a lot of the core technical stuff. But remember, the goal here is to get you job ready. So the big question is, how do we take all this knowledge and turn it into something a hiring manager actually cares about? Let's connect those dots right now.
Listen, a GitHub profile with real projects on it is way better than any resume. And you don't have to overthink it. Just start with these 3 simple but really effective portfolio projects. First, use Terraform to deploy a basic static website. Super easy. Then, try setting up a simple virtual network with a couple of subnets. And finally, spin up a managed database. Doing these 3 things proves you can take a project from start to finish. It shows you get it. Now, in a real job, you're probably not going to be running Terraform Apply from your own laptop. That's just not how it works. Instead, you'll use something called a CI/CD pipeline. The flow usually looks like this. You push your code to GitHub, that automatically kicks off a tool, maybe GitHub Actions or Jenkins, which runs a Terraform plan. Then someone on your team reviews that plan, and only when they say, okay, looks good, does the apply actually happen. Just showing that you understand this process, that's a huge plus in any interview.
It's also really good to know where Terraform fits into the bigger picture. I mean, sure, AWS has its own tool called CloudFormation, and Azure has Bicep, but Terraform's superpower is that it's cloud agnostic. What does that mean? It means it doesn't care which cloud you're using. You learn one language, one workflow, and you can use it to manage stuff on AWS, Azure, Google Cloud, you name it. That's why companies that use more than one cloud absolutely love it.
All right, let's get you prepped for that interview. You can bet they're going to ask you questions like these. So, explain the Terraform state file to me. Why is it so important? Or, what's state locking and what problem is it actually solving? And for sure, when should I use a module instead of just a regular resource? Nailing your answers to these shows that you don't just know the commands, you actually understand the fundamentals.
Look, mastering Terraform isn't something you do once and then you're done. It's an ongoing journey. So once you feel really comfortable with all the basics we've talked about, there are a few more key areas you'll want to explore to really level up and become a well-rounded engineer. So let's take a quick look at what's next.
First up, security. In today's world, security is everyone's job. You'll hear this term, shift security left. All that really means is finding and fixing security problems as early as possible. And you can do this by plugging free, open-source tools like Trivy, Checkoff, or Terrascan right into your workflow. They'll automatically scan your Terraform code for any common security mistakes before anything bad ever gets out into the real world.
And please remember this, you are not learning this stuff all by yourself in a vacuum. The Terraform community is huge, and it's full of super helpful people. I'm talking about the official forums, Reddit, special Discord channels. There are literally thousands of other engineers out there who are ready to help you when you get stuck. So don't ever be afraid to ask a question.
All right, you ready for a quick pop quiz? Just to make sure this is all sinking in. First question. Before you make any changes, what is the one command you should always run to get a safe preview of what's about to happen? Go on, think about it. If you said Terraform plan, you are spot on. It's your most important safety net. Okay, last one. Why is that whole idea of remote state locking so incredibly important when you're working on a team? The key, remember, is that it stops 2 people from running apply at the exact same time and potentially corrupting your single source of truth, that all-important state file. It's the thing that keeps teamwork safe and orderly.
And there you have it. That's your roadmap. You've got the foundational knowledge, you've got the career advice, and you know what the next steps are to really get good with Terraform. You know, the concepts themselves are pretty simple, but what you can do with them, it's limitless. So the blueprint is officially in your hands now. The only question left is, what are you going to build?